Welcome to the Data Future channel. This is Shekhar and I am a data scientist. So in this particular session, we are going to develop a predictive system which can predict the house price based on the different attributes of the house. Now, this is the regression problem because our target variable is the continuous value. So whenever the target variable is a continuous value, then we have to use the regression, and when our target variable is the classes, then in that case we have to use the classification model. Okay, so let's get started. So first thing is you have to import all the required libraries. So the libraries like pandas, numpy, matplotlib, and seaborn. So basically the matplotlib, seaborn, matplotlib and seaborns are the data visualization, where the numpy and pandas are the data manipulation libraries, right? So here the second thing is we have to load the data. I'm using a pd.read underscore csv and giving the file name. So you will see the data. Now you can see here the first column is the price. So this column you have to predict. So our target variable is the price in this case. Okay, and this is the supervised learning because here we are providing the label data. Okay, and the rest of all the variables are called as the predictors or the independent variables. So area, bedroom, bathroom, storage, main road, guest room, basement, hot water heating, air conditioning, parking, preferia, and furnishing status. Okay, so you can see that some are the numeric and some are the categorical variables, right? So based on that you have to predict these things. Now I'll check this, what is the size of the data. So 545 records are there. So 545 house data is available with 13 columns. Out of that, one is the price column, which is target one out of, and the 12 columns are the predictor. So by using a 12 columns, you have to predict the price. Okay. So here I'm using a dot columns to list down the columns. Then I'll check what is the data type of each column. So here you will see these are the objects and means a categorical one. Here you will see yes, no here. And furnishing is also categorical. Rest of all are the numeric one. You can check the information about it. So non-null values you can check. From here itself you can see that there is no any null records available or missing values are present in any column. So no need to worry about the data cleansing part. I'll check duplicates are present in the data set or not. I'm using dot duplicated dot any. It's saying false means there is no duplicate. I'm checking whether there is any missing values are there. Is null dot sum. So you will see no column is having the missing value. Okay, so now I want to check, suppose we are having hundreds of columns. In that case, we have to separate out categorical and uh, the numeric columns so that you can work with them, right? So I'm here using directly house df dot select underscore d types and include object dot columns. Include object means what? It will show only the categorical columns. Now these are the categorical columns. It will give the list. The same thing, you just have to provide the the exclude argument and object, right? So you will get here the numeric variables, right? Or the attributes or the columns, we can say. Okay. And now dot describe will give you the summary, statistical summary of the numeric variables here. And from that you will give main, max, these things. Okay. So let's check one thing. So suppose I want to check the attributes of the house whose price is maximum. Okay. So you can check here. This I'm using here the condition which is maximum, right? This is maximum. So you will see that this is the house with maximum price. Okay. Now house with maximum area I want to check, but what is the misconception here? you will see that the area is 16,200 square feet, but the price is lesser than this. Why? Because the rest of the attributes also plays very important role. So here you can say this stories is three. Here is the two bedrooms are here four, here five, bathrooms are here. But the thing is that you will see here some of the attributes are very important, where air conditioning, here is no parking available here, which is very important. Prefria is no here, and this is the furnished flat actually, and this is unfurnished. Because of that, there is a the price, though the area is more, price is less than this. So yes, like this, you have to just find out the insights from this particular data. Now, next thing is for the categorical attributes, we want to check the value counts of each and every column. So I'm running a for loop and using a housing df call dot value counts, right? So here you will get this yes no for main road, guest room, and finally very important is furnishing. You can see most of the homes are having the data with this thing semi-furnished, then unfurnished and furnished one. Okay. So next one is the part of the data visualization. You will see I want to visualize the data. If I want to visualize the data, the numeric variables can be visualized with the histogram or the KDE plot, where you can see the distribution of that particular column, or you can use the box plot. Okay, and yes, or scatter plot if you want to see the relationship between the two numeric variables, right? So here I am using a for loop again and using pl2.hist, and for each column I am plotting the histogram and providing the title to this also, and I'll use the pl2.show. So you will get the it for the price. Price is right skewed. Area is also right skewed. Here's the bedrooms, bathrooms, storage, parking. This is all about the numeric one. So we want to plot the box plot also with the same way. Box plot gives you idea about the five number summary, and also it can show the outliers. So here price you will see the outliers. The outliers are the points which are beyond these whiskers, upper and lower whisker. So each column is uh, uh, having this thing outliers, but this area and the price is more outliers. Okay. Then I want to use the count plot sns.count plot to plot the categorical values count. Basically, we have used here the value counts here. So simply you just have to use the count plot. So you will get the idea about this, right? No, here. So you will see main roads are there, the air conditioning, preferia, then furnishing status. So here you will get this uh, nice comparison between these categories. The next thing is the correlation matrix actually. So if you want to check the multicollinearity for the regression, so if there is a multicollinearity, then you have to just remove that correlated variables, because they can reduce the predictive power of the model. So we have to check the correlation by using a Pearson correlation matrix here. So simply by using a .corr function, and if you can check, you will get the nice visualization. So price is correlated because price is the variable target. So among these variables, if there are any correlated variables are there or not, we can check. But from this particular case, you will see some of the variables which are correlated is bedroom and bathroom, bedroom and storage is 40% around. So you can check it by using this matrix, or you can plot it by using a heat map simply. Okay, so by using a heat map, you will see this thing. So price and area is highly correlated, but among this, the bathroom and the price is correlated, but we want Bedroom and storage is somewhat correlated. Then here bedroom and storage is already there. Then 37% is a bathroom and bedrooms are 37%. So there is no any high correlation is seen among this. So it's a good thing. So we'll plot because the highly correlated with the target variable is the only area. Okay, and second thing is 51% was there, which was bathroom is also 52%, right? So you will see that here there is a relationship by using a scatter plot. Okay, so good. Now this is all about the visualization. Now we have to prepare the data for the model building. So for that, first thing we have to decide what is target and what is independent variables. So our target variable is price, and the rest of all are the independent variables, right? So I'm dropping it from this data, the price column, okay? Then I'll get the X. Y is yes, this one. So X and Y data is ready. So capital X and Y, right? Now next thing is now data is some categorical values. So categorical values we have to convert into numbers like 0, 1, 2, 3, or furnishing is 0, 1, 2. Okay. So instead of using a label encoding, because label encoding directly you can use from the sklearn preprocessing import label encoding, and you just apply it for each and every columns which are categorical one by using a for loop here like this le.fit underscore transform. Okay, but what is here? I'm using a simply a function, lambda function, and I'll do that. Okay, so we are having the columns which we want to convert into numeric one, which are the categorical, these one. So I'm running this for loop and I'm applying a lambda, which is the anonymous function. X is equal to 1. X is 1 if x equal to s, means whenever there is a s, it will assign one value, otherwise it will assign 0. So it's a one liner I'm using, and I'll run this. You will check now this 0 1 0 1 you will see. So on main road it's almost one. Yes, 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 yes. Here you will say 1 1 1 1. Here is a no, 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 and this is yes. No, 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 and this is yes. Okay, now this is converted, but one thing is remaining, that is furnished one. For the furnished, what I'll use, if x is equal to furnished, then I will assign two value. Semi-furnished, I will assign one, and otherwise it will be 0. Why I'm doing like this? Because furnished means it is having a higher weightage, semi-furnished is somewhat lesser, and this is 0. So just like order is there. Okay. So I'm writing this function, the furnished status, and applying that function to this particular column by using a lambda. Again like this condition. Okay. Now when I run this, you will see our furnishing status is also changed into 2 to 1, right? 2 is furnished, 1 is semi-furnished. Okay, good. These things are done. Now, next thing is you can see here from the data, some numeric columns are there, area is there, bedroom is there, bathroom is there, storage is there. These columns and the parking, these columns are numeric one, but they are on the different scale. So whenever the algorithms like linear regression, we just have to bring these all the columns, the attributes on the same scale, so that it will be easy for the to reach the solution quickly. And for that we are using a feature scaling. So the feature scaling is required for these four columns. Okay, these four columns, and here I'm using what sorry I'm using a min-max scaler. You can use the standard scaler, but basically standard scaler is used for the normal distributed data, and min-max scaler is used for the skewed data simply. So I'm using a pre-processing import min-max scaler, and when you run this, okay, so I'm creating the object of it, and I'm applying this to these columns. So feature to scale one by one, and I'm using this dot fit underscore transform. When you run this, you will get these values. Now you can check everything is now scaled. The data is encoded. Now data is ready for building. So next thing is building the model. So next thing is we have to train the split the data into training and testing by using a train test split function. Here we are creating a four variables where x train, y train, x test, y test. And here we are using a 20% data for the testing and 80% data for the training one. Okay. So when you run this and check the what is the shape of the training and testing data set. So these are the training and testing data set. Okay. Yes. Now next important part is we have to develop a model. So here we are just developing around 8 models. For from the linear, we are developing linear regression, lasso, and ridge. For tree-based, it's a decision tree, ensemble technique, random forest regressor, ensemble technique, it's a extra tree regressor. Okay, these three and neighbors, k neighbors regressor, and SVM is the support vector regressor also. Okay, this thing. Okay, fine. So just run this and okay. Now, next thing is I'm importing a matrix also. So how to evaluate the regression model? This is by using accuracy, and accuracy in this case is nothing but the R squared, R squared value. So and the mean squared error. So mean squared error should be low, and R squared value should be approaching to the one, means it's a good model actually. So I'm importing this matrix also. Now here is the model, which is linear regression model. I'm creating object of it. Then I'm fitting this model, means training is happening here. Then prediction is happening here. This model dot predict x test, and I'm using the R2 square here for x y test y predictions, and I'm multiplying with the 100 and taking a 2 decimal places only by using a round. So that, and MSC is round, again mean squared error, y true and y test. Again round function is used to get 2 decimal places, and just here printing the results score and the MSC. You will see, yes, 64.95% accuracy with the linear regression model. Okay, fine. So I will going to build in one shot all the models, and we'll check the accuracy score of these models. Okay. You know that we have already imported this matrix. Okay. Now, here the linear regression reach, we have created all the models with this object. I'm creating the list of object of these models here, and one by one I'll taking model by using a for loop. I'm fitting the model to the extent whiting and just predicting this model. Okay, then I'm using a score, that is R2 score, and MSC, that is mean squared error, and I'm printing the name of the model, its score, and the MSC. I'm providing this line and the space. So you will see there's a nice visualization of the score of each and every model. So out of these models, you can see that linear regression 94.9, 64.95, ridge is 64.88, lasso is 64.95, decision tree regressor is 38%, random forest 62, extra tree regressor is 62, then k neighbor regressor is 50, and SVR is very bad model, it's a minus 10.16. Okay, fine. So here you can see this is the best one. This is also a best one. So my favorite is linear regression model, right? You can use the cross validation score also here. I'm only changing is that I'm using a cross validation score, model, features, labels, scoring is R2 and CV is 5. So I'm creating a 5 folds, and simply I'm storing this accuracy, mean accuracy actually. So because cross val score will generate a 5 accuracies based on the folds, and we have to take the mean of these accuracies, and we have to store that accuracies in the list and model in here. And I'll create a data frame of it. So here you will see the accuracy, cross-val accuracy for each and every model. So these are the 7 models, and here you will see the accuracy of these models, right? So the best model is, yes, obviously it's a linear regression and the lasso. But we will develop a model, predictive system with the linear regression here. So for that, I'll take the user input for each and every variables like area, enter the area of the house. Then I'm using a transformation like minimax scalar transformation because that is very important here. So that area. Then second one is the bedrooms, number of bedrooms, bathrooms, like this. And I'm using these variables as a data here. So I'm creating a tuple, or you can create the list of it. Then I'm converting that data into array. Then I'm reshaping it here because we have to convert into 2D matrix or the array. And then I have to use the linear regression model to the predict house data, right? Then the price, so it will give the price of the uh, price of the house. Okay, so let's get started. When I run this, what is the enter the area of the house? So area of the house is suppose 1200 square feet. The number of bedrooms is 2, bathroom is 2, storage is 2, the main road is available, yes. Guest room is available, no. Basement is available, no. Hot water system is yes. Air conditioning is yes. Number of parking is 2. And pref area is yes, no. And enter the funding strategy. Yes, it's a furnished flat. Yes, now we have entered this data from the user input. Now it will create this data by using this tree, and finally it will predict. So when I run this, I'll get directly the price of that particular house. So this is all about the whenever you provide the model, you just have to save that model for the future predictions, right? So like this, you are going to use this. But how to save this model? So for that, you just have to use the pickle. So import the pickle module here, and which file you have to save? Model model name. It's a house pipe trend model, I will say, and I'm using pickle.dump and this model LR. Which model? It's the model which is used for this LR is there, right? Linear regression model. Okay, LR, and that LR dot open file name and WB. So right, it's a binary file, right? So when you run this, so model will be written or the saved in this particular file. Okay. Now I want to use this model. Okay. So for that, suppose I want to use this model to predict the price of this one in the future. Okay, no need to run this all the cells. You just have to do one thing. You just have to read the model file, or you have to get this model from pickle.load, open the file name or the model name RB. So read binary. Okay, RB means read binary. So when you run this, the model is now available for use for the prediction. Now all this loaded model I will use for the predictions. So here we have to do the array conversion, then we have to reshape it, and we have to use the loaded model dot predict house data reshape. Means this data is used for this reshaped data here input. Then when you run this, you will get the price of the house. Means you can save the model as well as you can predict it by using this one. Okay, so this is all about end-to-end project where we have developed 8 regression models, and yes, obviously it's Good thing is we can save the model and we can use it for the future predictions also. Okay, so that's all from my side. If you have any questions, you can ask in the comment, and just subscribe this channel and support me for the interesting content like this. Okay, thank you. Thank